Guys, welcome to our channel. Today we are going to learn about time complexity and Vigo notations. What are the topics we are covered today means what is time complexity, why it is important, why should we care about time complexity and what is Vigo notation, purpose of Vigo notation and why Vigo notation is important. These intro topics are we have to cover today. Come let's see what is time complexity. Time complexity is a way to express the amount of time an algorithm takes to complete as a function of the input size. It helps us to understand how our code scales and performs under different conditions. Let's decode it. Um, Imagine you have a magical bag that can hold as many candies as you want. Now, imagine you want to find a specific candy in that bag, like black color candy, red color candy, something. The more candies you have, the longer it might take to find the one you are looking for. Time complexity is a way to measure how long it will take you to find the candy as the number of candies or the size of input increases. It's like saying, how much time will I need it if I have 10 candies? Think of it, what about 100 or 1000? Did you understand what is time complexity? Find a candies in a bag. It has 110 or 1000 something. What are the time it takes to find it? This is the time complexity. Why it matters? Why we have to understand the time complexity? It's crucial to write a code in efficient manner. Let's say you are throwing a big party and you have to find all the red candies from a bag of 1000 candies. If your method for finding candies is slow, your guest might get bored for waiting. But if you have a super fast way to find the candies, everyone is happy and the party goes on. In programming, time complexity helps us figure out if your way or algorithm of solving a problem will be fast enough, especially when there is a lot of data involved. Why should you care about time complexity? Um, I share you a real world examples. Finding a name list in a book. Imagine you have a list of friends' names on paper. Think a scenario one. In the list, you have five names. Finding a name is quick no matter how. Scenario two. The list has 500 names. Now, if you go one by one, it will take some time. But if the list in but if the list is in alphabetical order, you can quickly skip to the middle, see if the name is there, and cut your search time into half. This faster way to searching is what programmers aim for, getting things done quickly, even when the list is huge. How to visualize your time complexity? I think I told another example to understand clearly. Imagine you are raising your friend to find a toy in a big box of toys. Box, if box has only 10 toys, everyone finds toy pretty fast. But if there are 1000 toys, suddenly it matters who has the faster way to search. It has two methods, one slower method and faster method. Slower method checking one toy at a time. Faster method splitting the toy box into half each time you look, so you can quickly narrow down where the toy is you have searched. When you use the faster method, even as the number of toys grows, you still find the toy much quicker. That's why time complexity is all about finding the best way to get the job done, no matter how big the task is. I think you are all understand about the time complexity. Now we move to another topic, big O notation. What is big O notation? It is a way to describe how the time or space needed by an algorithm grows as the size of the input increases. It helps us to understand the worst scenario for an algorithm performance. All must think big O notation is like a rating system that tell us how quickly an algorithm time or effort increases as the problem size gets bigger. Imagine you are playing different games and big O notation helps you figure out which game will take more or less time depending on the number of players. Okay. What is the purpose of big O notation? It helps us to understand how efficient an algorithm is, especially problem size grows. Big O notation helps us to understand. Imagine you are in a candy sorting competition. A set of members playing a candy sorting competition. You and your friends have to sort candies into different colors as quickly as possible. There are few different strategies you can use. I think I can suggest three strategies. First is go and grab method. What is mean by go and grab method? You just grab one candy at a time, check its color, and put it in the right bin. No matter how many candies there are, you always grab just at one at a time. This is like order of one complexity. Another method is one by one sorting. You sort through the entire pile of candies one by one. The more candy there are, the longer it takes because you have to check each one. This is like order of n time complexity. Another method is pair and sort method. You decided to pair up candies before sorting them. For each candy, you have to compare it with every other candy to make sure it goes in the right bin. As the number of candies increases, the number of comparison grows really fast. This is like order of n square time complexity. Did you understand the purpose of big O notation? What are the important of big O notation? Big O helps you to pick the best strategy depending on how many candies or how much data you have. If you know you are going to have a huge pile of candies, you will want to avoid the pair and sort method because it will take forever. Two key takeaways, efficiency matter and scalability. What is efficiency matter? Bigo tells you which method will take least time as your task. It's a efficiency matter. Scalability helps to understand an algorithm will perform an input size grows. Will it still be fast with more candies? Okay. Let's visualize. You are in a candy sorting race. Go and grab method, a super fast racer who doesn't slow down no matter how many candies are there. One by one method, a steady sorter who slows down as more candies are added. Pair and sort method, a struggling starter who gets overwhelmed with too many candies. Graphically imagine a race where the x-axis represents the number of candies and the y-axis represents the time taken. Order of n term complexity is a grab and go and grab method. The razor or line stays at the same speed, no matter how many candies. Order of n method, one by one. The razor speed decreases steadily the more candies are added. Order of n square, it's a parent sort method. The razor almost steps as the number of candies gets held. I think you can understand what is big O notation and the purpose of big O notation, importance of big O notation. Thanks for turning in. Now you have got a solid grasp of time complexity and big O notation. These concepts are key to understanding how algorithm works and how they scale as problem grow. Remember, the goal is to make your code as efficient as possible. Keep practicing and soon you will be a pro at analyzing and optimizing your algorithms. Don't forget to like, share and subscribe for more simple and fun tech explanations. Thank you.